Thank you for your previous views and most shares and like this video. Now I am discussing about the register. So welcome to our channel Tech Knowledge. मैं हूँ आपका ललित. And now we are discussing about the registers and the types of register. Actually nowadays in our electronic circuits we are using register. We are using different type of electronics elements, but the most commonly used electronics element, that is the register. So now today we are discussing about the register. Okay, so first thing, so we are discussing that what is the register, the types of registers, the connection of the register color code, and the register power rating. So before going through this chapter, that we are know about the what is the register, it means whom it called a register, the what type of registers are available in our world, and the connection of the register, that how the registers are connected, and the register color code, that how we know the value of a register, and the register power rating, it means how can we calculate the power rating of a register. Okay, so at first, what is register? So a register is a passive two terminal electrical component that implements electrical resistance as a circuit element. Okay, so register is a passive element. It means in the whole electronic circuit is divided into two parts, that is an active element and a passive element. Active element means it have a ability to develop energy by itself, but the passive element, it means it does not have that capability, that ability to develop energy by itself. So register, there is three passive elements, that is resistor, inductor and capacitor. So we are discussing about register. So register is a passive two terminal device. I will show you the picture after that how the register look like. And register is a two terminal device, and actually the main part is the main work of a register is it is the element which opposes the flow of current. Here in the second definition you will see that the ratio of the voltage applied across a resistor terminal to the intensity of the current through the circuit is called the resistance. So here you see the relation, that is the relation is presented by a Ohm's law. We know Ohm's law, that is V is proportional to I. So here V equal to IR. Here V is the voltage applied across the circuit, I is the current flowing through the circuit, and R is the resistance. Okay. Then the unit and symbols. Okay, so as the register is a electronics component, so it has some unit and also symbols. So here we see the ohm, the symbol, there is also the symbol of ohm. It is the unit of a electrical resistance, and it is named by a scientist George Simon Ohm. And ohm is a equivalent to the volt per ampere. It means I will show you that relation, that is V equal to IR. It means if we will compare this equation with this line, that an ohm is the equivalent to a volt per ampere, it means R equal to V by I, it means V is the volt and I is the ampere. Okay, then here we are seen then the other derived units are milliohm, that is 1 milliohm equal to 10 to the power minus 3 ohm, kilo ohm is 10 to the power 3 ohm, and mega ohm also 10 to the power 6 ohm. Okay, then after that there is the diagram, the symbols of the register in the electronic circuit. Actually we are seeing the electronic circuit, then in the electronic circuit, that how we know it is a resistor, it is an inductor. For this is the symbol of a resistor, and there is the symbol of the variable resistor. Okay, so after some time I will discuss about what is the fixed resistor and what is the variable resistor. The types of resistor. In the types of resistor, you will see that resistor are two types. Okay, there is a fixed resistor and there is a variable resistor. So here we see that there is the partition of the fixed resistor and there is the partition of the variable resistors. The fixed resistors are the carbon composite resistors, film resistors, wear round resistors, and the resistance wears. Okay, and the variable resistors are rheostat, potentiometer, thermistor, humistor, varistor, and photoresistors. Okay, then at first we are discussing about the types of the fixed resistor, after that the variable resistor. Okay, at first we are discussing about the carbon composite resistor. So you can see in the figure, this is the carbon composite resistor. These are the very old resistors, and you can also see the internal architecture of this resistor. These are the outside of the resistor is a insulating metal, and the inside of the resistor is a carbon mixture. And there is also, I am telling you, there is two leads of resistor. So these are the two leads you can see in this diagram. So what is the description of this resistor? That is, the resistor is low inductance. The resistor is low inductance, ideal for high frequency appliances. Today what electronics appliances we are using, these are the high frequency. So it is, these resistors are also used in these appliances. Very cheap to make. It means the resistors are very low, in very low cost, and have very large tolerance limit. So we are know about what is the tolerance limit of a resistor. It means if we take a resistor having a tolerance limit 10%. It means if a resistor have the resistance value that is 10 ohm, it means that value may be vary within may be increase up to 10%, or the value may be below 10%. Okay. So the next, there is the film resistor. Okay, in the film resistor you are also seen in the day-to-day life circuits. What circuits we are got, you are seen in this type of resistor. And this is in the below of the picture, there is the internal architecture of the resistor. And the resistive value of the resistor is controlled by increasing or decreased the resistive value of the resistor is controlled by increasing the desired thickness of the deposited film. So by increasing the deposited film, it means the increasing the deposited mixture inside the resistor, we can able to increase the resistance value. Okay, the resistance up to 10 mega ohm can be obtained. Okay. This film resistor is maximum give the resistance up to 10 mega ohm, and the tolerance limit is very less, that is 1%. It means it is a very accurate resistor. It will give the accurate resistance always. Then the wear round resistors. So you can see in the picture, this is the wear round resistors, and you can also see the internal architecture of this. So wear round resistors made by a winding a thin metal alloy wire on to an insulating ceramic former in the form of a spiral helix. These resistance are available in a very low resistance ohmic value. Okay, and the resistance may be vary up to 0.1 kilo ohm to 0.1 ohm to 100 kilo ohm. Then we are discussing about the variable resistor. These all are the fixed resistance, and this is the variable resistor, that is the rheostat. So you can also see the symbol of a variable resistor, that is you can see the diagram, pictorial representation. And the rheostat is a adjustable resistor used in appliances that require adjustment for current or varying of resistance in an electrical circuit. Let's think that we want to increase or decrease the voltage, or manage the voltage and current in a circuit. In this area we are using this type of resistance, because as our wish we are able to decrease or increase the voltage or current level in a circuit. A special type of rheostat is the potentiometer. So these rheostats are very old rheostats. Nowadays we are using potentiometer. So this is the potentiometer. It is also a variable resistor, but these are the very latest technologies now we are using. You are also seen the pictorial representation and the actual picture of the potentiometer. So a potentiometer is a port in electronics technology, is a 3-terminal resistor with a sliding contact that forms an adjustable voltage driver. Okay, so the potentiometer have a 3-terminal device. It means it has 3 terminals. Okay, so in 3 terminals, the middle terminal is used to vary the resistance. If we are vary the resistance, automatically the voltage drop will happen and we are able to control the voltage. So we are using the potentiometer. The potentiometer are commonly used to control the electrical drives such as volume control, joysticks, etc. And joysticks we are also using in our gaming purpose. These are also by using a potentiometer. And this is thermistor. Thermistor is what? A sensor. Okay. A thermistor is a type of resistor whose resistance varies significantly with temperature. So thermistor is a resistor, but it is like also a temperature sensor. When the temperature of the surrounding is increases, automatically the resistance will vary. Okay. Then you are also seen the actual picture of a thermistor, and below it is the picture. It is the notation. It is the symbol of the thermistor. And the thermistor can be used as a current limiting device for circuit protection as a replacement of fuse. Okay. Nowadays, instead of fuse, we are also using the thermistor. It means when the temperature of a circuit will increases, by the using of thermistor we can break the circuit. Okay. Then the humistor. Then you can also see the picture done representation of a humistor. A humistor is a type of resistor whose resistance varies significantly with humidity. Okay. So if the humidity, this is also a sensor, and if the humidity of a surrounding is increases, then automatically the resistance of a resistor will vary. Okay. Then a humidity sensor measures the humidity level by measuring the change in the resistance of an element. Okay. And after that, the varistor. Okay. You are also seen the pictorial representation. This is the high voltage varistors, and this is the very low voltage varistors. And the varistor or a voltage dependent resistor. Okay. The function is to conduct significantly increased current when the voltage is excessive. Okay. Then the photoresistors. So photoresistors is like a sensor, and it is also called as LDR. It is the light dependent resistor. So photosensor is mainly consume items such as street lights, clock, radios, alarm, etc. It means it is also nowadays the automatic street light is very much commonly used in our day-to-day life. So here the LDR is used to automatically on off the light. Means when the light is fall on this sensor, on this photoresistor, automatically the resistance of this sensor will increases, so that the current cannot conduct through it, so that the light will be turned off. But in the night time, automatically the resistance of the sensor body will decreases, because there is no light will put on this sensor, so automatically the light will on. In this type, by using this type of sensor, we are automatically on of this light. Then we are discussing about the connection of the resistors. Okay. So here we can see that actually in the normal day-to-day life we are making two type of connections, that is a series connection or a parallel connection. So in the whole circuit, if you study a circuit, we are seen that the whole circuit will conduct only two type of connection, that is a series connection or parallel connection. So if we see that if the resistors are connected in series, then what the formula, what is the equivalent resistance we get? Okay. So here we see that the R1, R2 up to Rn, the resistors are connected in series. Okay. Series means the one end of a resistor, the end of resistor will connected the first end of another resistor. It means we are seeing that the R1, in the R1 resistor, the end of the R1 resistor will connected with the starting end of the R2 resistor. So they all are connected in series. So if the resistors are connected in series, then what will happen? The equivalent resistance will be R1 plus R2 Rn. If there is 3 resistors, then R1 plus R2 up to R3. If there is 4 resistors, then R1 plus R2 plus R3 plus R4. As there is n number of resistors are there, so the equivalent resistance will be R1 plus R2 up to Rn. Okay. So in series connection, the current remains constant. Okay. In the series, we see that in the series connection, the I1 equal to, if in resistor R1 the current across it may be I1, in the resistor R2 the current across B may be I2, then the whole current will be equal. It means the I1 is equal to I2, it is equal to I3 up to equal to IN. You are seeing the equation. Then but in series connection the voltage will divide. It means the whole voltage is equal to the sum of all the voltages developed in the resistor. It means that let the total voltage will be V. It is the sum of the total individual voltage induced across resistor. It means let the voltage V1 induced across R1, let the voltage V2 induced across R2, and let the voltage Vn induced across Rn. So the total voltage equal to V1 plus V2 up to Vn. Okay. Then we will discuss about the parallel connection. So in the parallel connection you will see that you are seeing the pictorial representation, that is the R1, R2 up to Rn. These all are connected in parallel. Okay, you see the how the resistors are parallelly connected. You are seeing it by this picture. Okay, so if their resistors are connected in parallel, then what is the formula? Okay, the formula is 1 by R equivalent is 1 by R1 plus 1 by R2 plus dot 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 up to 1 by Rn, because n number of resistors are connected in parallel. So if the resistors are connected in parallel, then the voltage remains same. Okay, so what V we are applied in the first terminal, this V is induced across R1, this V will induced across R2, this V will induced across Rn. So the voltage is same across R1, R2 and Rn, but in this parallel connection the current is divided. Here we are seeing the equation, that is I1 equal to I2 plus I3 up to Rn, because as there is n number of resistors are connected in parallel, so the number of current are divided, that is I1, I2 and In. Then we are discussing about the color code of a resistance. Okay, so here we are seeing that actually there is 10 colors of a resistance may happen. Okay, 10 colors means the 0 is this. You can see that this is the color code table of a resistor. There is 12 colors are available, that is you can see in this whole table, and the color code can be calculated by this and this formula. This is the resistor value and the XY. You can see all this. If you see this diagram, you can automatically know then how the color code is calculated. Then after that the power rating of a resistor. Okay, then the resistor power rating. The power rating of a resistor can be calculated by using this formula, that is P equal to Vi or P equal to I square R or P equal to V square by R. The larger power rating, the greater of the physical size of a resistor. It means if we increase the power rating of a resistor, automatically the size of the resistor will be increased. When we used in AC circuit, the AC impedance of a resistor is equal to its DC resistance. Okay. So thank you for watching this video. If you like this video, then please comment, like and share. And if you got any type of doubts about this video, you can ask in our comment section. And if you want to see this type of video again, then please subscribe our channel Technology. Thank you.